Hi all, welcome to previous year question paper discussion of physics from the chapter Light, Reflection and Refraction. Now we are going to the questions. Now our first question, at what distance from a convex lens should an object be placed to get an image of the same size as that of the object on a screen? Especially questions from light chapter, first of all you need to understand the given question is based on mirror or lens and which lens, which mirror. So here we can see that the question is based on convex lens and the question says that the image is same size. So the question is based on characteristics of our ray diagrams. So you can see the option A is beyond twice the focal length of the lens. We know that if the object is kept beyond 2f, the image will be between f and 2f and the nature will be real inverted and the size will be diminished. So option A is the wrong one. Now you can see the second option at the principal focus of the lens. At focus, if the object is kept, we know that the image is at infinity and it will be real inverted and highly enlarged image. Now option C, look, at twice the focal length of the lens. So if the object is kept at 2f, we know that the image will be at 2f and the size will be same size and the nature will be real inverted. So the answer for this question is at twice the focal length of the lens and we know that the nature is real inverted. And we will see the option D, between the optic center of the lens and its principal focus. Last option, we can see that it's based on the last case of our ray diagram. So here if the object is kept between optic center of the lens and its principal focus and we will get a virtual, erect and enlarged image. So answer for this question is at 2f. Now we are going to the next question. The speed of light in vacuum is 3 into 10 raised to 8 meter per second. If the speed of light in a medium is 2.25 into 10 raised to 8 meter per second, your question is to find out the absolute refractive index of the medium. We know that absolute refractive index n is equal to speed of light in vacuum divided by speed of light in medium. Now in the question, what are things given? Speed of light in vacuum given 3 into 10 raised to 8 meter per second and speed of light in the medium given 2.25 into 10 raised to 8 meter per second. All the values we have, we need to just substitute on this given equation. So this will be equal to 3 into 10 raised to 8 divided by 2.25 into 10 raised to 8. So this 10 raised to 8, 10 raised to 8 get cancelled. So to avoid the decimal, you know that you can multiply with 100. Here also multiply with 100. So this will be equal to 300 divided by 225. So we can see that both are divisible by 5. So 6, 5, 300, 6, then 65 are 300, then here 4, 5, 20, 5, 5, 60 by 45. We can again divide it with 5. So both are divisible by 5. 12 5s are 60 and 9 5s are 45. Now both are divisible by 3. So 4 3s are 12 and 3 3s are 9. So you can see your option, yes, option C, you can see that 4 by 3. So 4 by 3 is the correct answer. Now next question. Absolute refractive index of glass and water is. So given question says absolute refractive index of glass and water 3 by 2 and 4 by 3 respectively. If the speed of light in glass is 2 into 10 raised to 8 meter per second, the speed of light in water you need to find out. Now each values we can write absolute index of glass given, that means Ng. So absolute refractive index of glass is 3 by 2, that is Ng equal to 3 by 2, and absolute refractive index of water given 4 by 3. So we can write Nw equal to 4 divided by 3. If the speed of light in glass is 2 into 10 raised to 8, so velocity of light or speed of light in glass given 2 into 10 raised to 8 meter per second, and your question is to find out the speed of light in water. So we can write it as VW. So we need to find out the speed of light in water. So there are different ways to find out this. If you want, you can first find out the speed of light in vacuum using any one of the given values. You know that n equal to c by v. Or directly using, without finding the c value, we can directly find out using our relative refractive index concept. We know that relative refractive index is n21. Refractive index of second medium with respect to first medium equal to n2 divided by n1 equal to v1 divided by v2. So here we can consider glass as the second medium and water as the first medium. So we can replace this equation as ngw equal to ng divided by nw equal to vw by vg. So here you can see that as per the given question, ng is there, nw is there, then vg is there. So just by substituting, we can easily find out the velocity or speed of light in water. So we can substitute the given values. So ng 3 by 2, so 3 by 2 divided by nw 4 by 3 equal to velocity of light in water you need to find out. So keep it like that, vw divided by speed of light in glass already given in the question, 2 into 10 raised to 8. Now LHS you can write like this, 3 by 2 into 3 by 4. You know that division is reciprocal multiplication. So this will be equal to Vw divided by 2 into 10 raised to 8. So our aim is to find out speed of light in water. So keep that speed of light in water on RHS and take that 2 into 10 raised to 8 to LHS. So speed of light in water equal to 3 by 2 already there on the left side into 3 by 4 into this division become multiplication, 2 into 10 raised to 8. So you can see that this 2 can be cancelled. Then 3 into 3, you know that 9 divided by 4 into 10 raised to 8. Then 9 by 4, yeah, it's there in the option. So 9 by 4 into 10 raised to 8 will be our answer. I already told you, this is a direct method without finding the speed of light in vacuum. Or you can find out ng, vg you have. So ng equal to c by vg and c value you know, or you will get, then nw equal to c by vw. Directly you can find out using that method also. Now the next question is, okay, how will the image formed by a convex lens be affected if the upper half of the lens is wrapped with a black paper? Yes, so we can consider a convex lens. Now let f1 be the position, f2, f1 be this position, let it be f2, let it be 2f2. Now imagine we are keeping an object at 2f1. So you know that ray coming parallel to principal axis after refraction passes through the focus, and you can consider any of the other rule. So a ray passing through the optic center goes straight without any deviation. You can see that image will be formed at a focus. So we will get a real inverted same size image at focus. But here the question is, saying that the upper part of the convex lens is wrapped with a black paper. So let us consider this portion is covered with a black paper. You know that only the upper half of the lens only covered. So light can easily pass through the lower part of the lens. So what we will get? We will get the image completely, but the brightness or intensity of the image will get reduced. So what will be our answer? You can see the option, the size of the image formed will be 1/2 of the size of the image due to completed lens. No, the image of the upper half of the object will not be formed. That's also wrong. The brightness of the image will reduce. I think all of you got the idea correctly. Even though the one portion or 1/2 of the lens is covered with a black paper, lot of light rays are there. Light can easily pass through the lower part of the lens and you will get the image completely. Only the intensity of the image will get reduced or brightness of the image will get reduced. Now we will go to the next question. Yes. So you can see here, a ray of light is incident on a plane mirror at an angle of incidence 15 degree. The deviation in the ray produced by the mirror is. So we can consider a plane mirror. Let this be a plane mirror. Now we can draw the normal. Let this be the normal. Now, as per the question, it is given that ray of light is incident on a plane mirror at an angle of incidence 15 degree. Let this be the incident ray. As per the question, it is telling that the angle of incidence is 15 degree. So, this is angle of incidence. So, it is 15 degree given in the question. Now, you know that after incident here, the light ray will get reflected back. Let this be the reflected angle. You know that as per laws of reflection, angle of incidence is equal to angle of reflection. So, I and R will be same 15 degree. Now, your question is to find out the deviation in the ray produced by the mirror is. Deviation means actually the exact difference between the reflected ray and the incident ray. So, we can extend the incident ray. Actually, if there is no mirror present here, this ray want to travel like this. If this mirror is absent, or if the mirror is not present here, this light ray actually want to travel like this, straightly. Because of the plane mirror, it gets reflected and deviated its paths. So, angle of deviation can be find out, or the angle of deviation will be this one. This much angle we need to find out. We can represent, let it be capital letter D. This is the angle of deviation we need to find out. You know that this total angle is 180 degree. This total angle is 180 degree. So, we know that up to here 15 plus 15, 30 degree. So, angle of deviation, how can you find out? Angle of deviation is equal to total is 180 degree. And in this 180 degree, 30 degree already over based on angle of incidence and angle of reflection. Now, the angle of deviation is actually the angle between this reflected ray and this incident ray. So, 180 degree minus 30 degree. So, you can see that it will be 150 degree. So, the answer is option D, 150 degree. Now, the next question. If for an object, a convex mirror always forms an image, which is, we know that the question is based on convex mirror. Convex mirror can always form what type of image? It's none other than virtual, erect, diminished image. Only two cases are there for convex mirror. First case is object at infinity, you will get image at the focus. Second case, anywhere on the principal axis between infinity and pole, anywhere if you keep the convex mirror, again you will get virtual, erect and a diminished image. So, as per the option, you can see that option B, virtual, erect and a diminished image formed by the convex mirror. So, for an object, a convex mirror always forms an image which is, it's none other than virtual, erect and a diminished. Now, next question. Yes. Now, this question is based on numerical. So, an object is placed at a distance of 10 centimeter from a convex mirror. So, I already told you, especially the numerical questions also very important. You need to first understand the given question is based on mirror or lens. So, I underline the given mirror or lens. So, here the question is based on convex mirror. So, now an object is placed at a distance of 10 centimeter. Before doing this type of numerical, you should have an idea about the sign convention. Sign convention clearly need to remember, and the characteristics, ray diagram characteristics also you should remember. Then here object distance given 10 centimeter. So let U be the object distance and it is 10 centimeter. You know that object is always on the left side of the mirror or lens. Mirror or lens, not a matter. Object will be always on the left side. So object distance as per sign convention minus 10 centimeter. Then focal length given 15 centimeter. You know that for a convex mirror. Convex mirror means, you know, like this. This is our convex mirror. So when a ray coming parallel to principal axis, you can see that it's a diverging mirror. So after reflection, it diverges from a particular point, and that point is known as the principal focus. So the focus is on the right side of the mirror. So as per sign convention, focal length is positive. So here the given question, focal length given for the convex mirror, it's 15 centimeter, and as per sign convention, it is plus 15 centimeter. Now, your question is to find the position of the image. Position of the image means image distance, that is V, you need to find out. So, you need to find out V. Now the question is based on mirror equation, lens equation. Correctly remember, there is only a small change. If a small change or if a small mistake you done, then total mark will lose. So clearly remember, correctly study mirror equation and lens equation. Mirror equation is 1 by f is equal to 1 by v plus 1 by u. So we have f, we have u. Our aim is to find out v. For that, keep that v on the right side. So I am keeping this v on the right side. So 1 by v equal to this u I am taking to left side. So 1 by f minus 1 by u. Now all values we have just substituted the given values. That will be equal to 1 by f is 15. 1 by 15 minus 1 by u. U already minus 10. So this will be equal to 1 by 15 minus become plus 1 by 10. Now we need to solve this. We can use the LCM method or cross multiplication, any manner you can do. Now this will be equal to 1 by v on the LHS. 1 by v equal to cross multiplying. I am doing the cross multiplication method. 10 comes here, 15 comes here, then 15 into 10. So 10 plus 15 divided by 15 into 10 will be 150. So you can see that 1 by v equal to 25 divided by 150, or v will be equal to 150 divided by 25. And while dividing this, you will get plus 6 centimeter. So you can see that you can check the obtained answer is correct or wrong just from the given answer or obtained answer. You can see that it's a convex mirror. Convex mirror always image is forming on the right side of the mirror. So right side image is always what? Positive. So image distance always will be positive. So the answer is plus 6 centimeter. So position means position of image means you need to find out the image distance. Now the next question. Yes. A ray of light falls making an angle of incidence theta on the surface of a glass slab. The question is based on glass slab and refraction. Draw a labeled diagram to show its path. You need to draw a labeled diagram of a glass slab. Also mark lateral displacement on it. So we need to draw a glass slab first. So we can consider a glass slab. So let us consider a glass slab. Now this be the normal. You know that here it is refraction related question. So here we have 3 medium. This is air. Air, you know that it's a rarer medium. Now the second medium is glass. It's denser medium. Now the third one is again air, rarer medium. So your question is to draw a labeled diagram showing lateral displacement, and you need to mark lateral displacement. So you can see that here the ray is coming from the rarer to denser. So rarer to denser, you know that the ray will bend towards the normal. So after refraction here, the ray will bend towards the normal like this. And this is the angle of incidence. As per the question, they are telling that mark angle of incidence as theta. So we can mark this angle of incidence as theta. You know that angle of incidence means angle between incident ray and normal. So we can mark that angle of incidence as theta. Now again the second medium, you can see that the ray is on the surface of a second medium. Now it's denser to rarer. Denser to rarer, you know that it bent away from the normal. So denser to rarer, ray will bend away from the normal. And your question is to mark the lateral displacement. What is lateral displacement? Lateral displacement means it is the perpendicular distance between the incident ray and the emergent ray. So if this glass slab is actually not present here, this ray actually want to travel straightly, is it? So now we can draw that straight path of the ray. This ray actually want to go or move straightly like this. So this is the exact path of the ray if this glass slab is not present here. So this you can see here, this is the perpendicular distance between incident ray and the emergent ray. This ray is known as emergent ray. This is known as emergent ray, and this is known as incident ray. So you can see that there is a perpendicular distance between incident ray and the emergent ray, and this perpendicular distance is called lateral displacement. This is your lateral displacement, and the question says that mark lateral displacement. So this is the lateral displacement. So what is lateral displacement? It is a perpendicular distance between incident ray and the emergent ray. What are the factors this lateral displacement depends? It depends upon angle of incidence and thickness of glass slab, refractive index of glass slab. Now you can mark the other points also. This is angle of refraction and this is angle of emergence. In this question they are not asking to mark all this. They are just asking to mark lateral displacement only. So you just need to mark lateral displacement. Next time you can expect angle of incidence, angle of refraction and angle of emergence, all points to mark. Now next question, state two laws of refraction of light. So refraction means, just now the previous question is also based on refraction. If this is a transparent medium, let it be rarer and let it be denser. So you can see that, and you can draw a normal here. So when a ray of light travel from rarer to denser, you know that it bends towards the normal. So now how can you define the laws of refraction of light? There are two laws of refraction of light. First law is almost the same as our laws of reflection. That means incident ray, refracted ray, normal at the point of incidence all lie on the same plane. That's the first law. Incident ray, refracted ray and normal at the point of incidence all lie on the same plane. Now the second law is known as Snell's law. Second law is known as Snell's law. What is the Snell's law? It is the ratio of, you know that this is angle of incidence I, angle of refraction R. So Snell's law saying it is the ratio of sine of angle of incidence to the sine of angle of refraction will be a constant, and that constant is known as the refractive index of the media. So these are the two laws of refraction of light. First law is incident ray, refracted ray, normal at the point of incidence all lie on the same plane. The second law is known as Snell's law. The ratio of sine of angle of incidence to the sine of angle of refraction will be a constant, and that constant is known as refractive index of the media. So this is the first question. State two laws of refraction of light. Clearly remember these two laws. Now the second question, define the term absolute refractive index of a medium. So already absolute refractive index related one numerical we already discussed. So absolute refractive index we can represent it as N. So absolute refractive index means it is the ratio of speed of light in vacuum to the speed of light in medium. It is a ratio of speed of light in vacuum to the speed of light in medium, and speed of light in vacuum is always constant and its value is 3 into 10 raised to 8 meter per second. So whenever absolute refractive index related question coming time, you have to write the sentence or word first, then write this equation. Similarly, Snell's law just now I told, it is a ratio sine of angle of incidence to the sine of angle of refraction will be a constant. So first write the word, then write the equation. Here also first write the sentence or that definition correctly. It is a ratio of speed of light in vacuum to the speed of light in medium. And then after the definition, write this equation also. C value you know 3 into 10 raised to 8 meter per second. Now there is an additional question. A ray of light enters from vacuum to glass of absolute refractive index 1.5. So in the question it is given that n is equal to 1.5. So absolute refractive index, you know, we already told it is represented by the symbol n, and it is given in the question 1.5. Find the speed of light in glass. Your question is to find out the speed of light in glass. Glass is the medium here. So speed of light in glass you need to find out. And already speed of light in vacuum they given 3 into 10 raised to 8 meter per second. That already we written here. This value you should remember. Sometimes they will not be provided in the question paper. So speed of light in vacuum is 3 into 10 raised to 8 meter per second. So we have n, we have c, and we can find out v using the above given equation. So we can directly substitute these values here. So 1.5 phi equal to 3 into 10 raised to 8 divided by V. So you can rearrange the equation. So V will be equal to, you can transpose this, V comes here, 1.5 goes there. So V equal to 3 into 10 raised to 8 divided by 1.5. So 3 by 1.5, clearly you can write 2 into 10 raised to 8 meter per second. So this is the answer for this question. Speed of light in glass. Speed of light in glass is 2 into 10 raised to 8 meter per second. So definition related question, correctly remember, correctly study, and along with that definition, if there is an equation, write that equation also. So this is our A and B question. Now next question. Okay, now the heat produced at a point due to concentration of sunlight by a convex lens. So here the given optical device is a lens, and that convex lens burns a paper. Explain why it happens. You know that convex lens is what type of lens? Convex lens is a converging lens. So you know that first case of convex lens, if the object at infinity, so here you know that sunlight, here the object is sun, so convex lens focusing sunlight or the light from the sun. So object is at infinity. First case of our convex lens ray diagram, if the object at infinity, you know that image will be at focus. So the ray comes parallel, after refraction passes through focus. So one more ray we can draw. So you can see that this is the first ray diagram for convex lens. If the object at infinity, image at focus. So you can see that convex lens important property is converging. Convex lens is a converging lens. So here all the light ray will focus or converges to a particular point. You know that sunlight has heat. So if all the sunlight or sun rays from the sunlight converges or focuses to a point, clearly the paper will burn. So explain why it happens. What is the answer? This is because it's a converging lens. All the rays from the sun converges to a particular point, and that particular point heat will produce and the paper will burn. Now second question, name the term given to the point at which the paper starts burning. So this is the point. So all the rays are focusing to a particular point, and that point is burning, and that point is known as focal point. We can call that point as focal point. So we can call that point as focal point. Then there is an additional question also. What does the bright spot formed on the paper represent? That bright spot is actually the paper is screen. So here the convex lens form the image on the screen. Image of who? Sun. So image of sun is formed on the screen. So the bright spot is none other than image of sun. And a question I already told you, it's because of the converging property of convex lens. So the convex lens converges all the rays to a particular point. That's why the paper burn. So it's because of converging property of the lens. Now next question. Yes. The linear magnification produced by a spherical mirror is +3. Based on this statement, answer the following question. So the given question is based on magnification. So you should have an idea about magnification. So what is actually magnification? Magnification, here it's based on mirror. Magnification of mirror and lens, a small difference is there. Now the question is based on mirror magnification. So magnification of mirror is the ratio height of image to height of object. That will be equal to minus V by U. So this is the equation for magnification for a mirror. Magnification definition is the ratio height of image to height of object. It is same for mirror and lens. Now, magnification related any question coming time, remember this important property. If M is negative, its meaning is real inverted. Real inverted. If M is negative, it is real inverted. If this M is positive, it is known as virtual and erect. M negative means real and inverted. M positive means virtual and erect. Then if m value is equal to 1 means it's the same size. The image is same size. Now, if the value of m is greater than 1, it is known as enlarged image. Now, if the value of m is less than 1, it is a diminished image. So, you can clearly see here the sign, negative, positive sign represent the nature of the image, and the value, if it is equal to 1, same size, greater than 1, enlarged, less than 1, diminished. So, now we can go to the question, and these properties are same for lens and mirror, and this is very important one. All of you should correctly remember and study about this magnification property. Now the given question, it's given plus 3. Magnification is plus 3. M is equal to plus 3. Here, magnification related question, you have to treat sign separately, value separately. So, we can separate this sign and value plus and 3. Plus indicate that it is virtual erect. So, the given or the obtained image will be a virtual erect one. 3 indicate that it's greater than 1. So, it's an enlarged image. So, these are important properties we can identify from the given magnification. Now, we can go to the question. So, what is the type of mirror? Your first question is what is the type of mirror? So, the question is based on spherical mirror and magnification is plus 3. So, you know that the obtained image will be a virtual, erect and enlarged image. You know that convex mirror always form virtual, erect, diminished image. So, surely it's an enlarged image means it's none other than concave mirror or converging mirror. So, what is the type of mirror? Converging mirror or concave mirror. Converging mirror or concave mirror. Now, where is the object located? You know that it's the last case of concave mirror ray diagrams between focus and pole. So, object located between focus and pole. So, object is between focus and pole. Image will be behind the mirror and it is virtual, erect and enlarged image. Now, list 2 properties of the image formed other than size and magnification. 2 properties already we got, virtual and erect. So, 2 properties are virtual, erect. Plus means it's none other than virtual, erect, and size no need to mention because they are telling that other than size. So, enlarged image, again enlarged, that property no need to write. So, just 2 property they are asking. So, virtual and erect image is formed by this concave mirror. So, I think all of you understood correctly. So, remember magnification means it is a ratio height of image to height of object. Especially remember the characteristics based on magnification. Negative means real inverted. Positive means virtual and erect. If is equal to 1 means same size. Greater than 1 means enlarged. If magnification less than 1 means diminished. And this property is same for both mirror and lens. So, from now, based on the question, type of mirror, already you know, converging mirror, concave mirror is converging mirror, object between focus and pole, and properties already we discussed. Okay, now, next question is, list 4 properties of the image formed by a plane mirror. You know that plane mirror forms virtual image, virtual, erect, same size, laterally inverted, laterally inverted means you know that right side become left side become right side. So, laterally inverted image, then object distance is equal to image distance, then size of the image will be equal to size of the object or height of image will be equal to height of object, then focal length of plane mirror is infinity. So, they are just asking 4 properties. So, here you can see that 6-7 properties are there. So, remember these properties. Plane mirror always form virtual, erect, same size, laterally inverted image and object distance equal to image distance, focal length of plane mirror is infinity. HI equal to HO means same size, already we noted here. So this is enough. Focal length of plane mirror is infinity. Why focal length of plane mirror is infinity? That also you can expect as a short answer question. Focal length of plane mirror is infinity because you know the relation connecting focal length and radius of curvature f is equal to r by 2. The radius of curvature of plane mirror is infinity. That's why focal length of plane mirror is infinity. So that's the first question. So we need to go to the B question. Write the definitions of the following terms in the context of concave mirror. So the question is based on concave mirror. So we need to consider a concave mirror. Concave mirror means the mirror that curves inward. So this is a concave mirror. So now the first question, pole. You know that the midpoint of the mirror is called pole, or we can tell geometric center of the mirror is called pole. So this is same for both concave mirror and convex mirror. So the midpoint of the mirror is called pole. Now center of curvature. Center of curvature means if you consider this mirror as an imaginary sphere, so center of an imaginary sphere in which mirror forms a part. Center of an imaginary sphere in which mirror forms a part is called center of curvature. This is also same for convex mirror and concave mirror. Only one difference is based on sign convention. For convex mirror, center of curvature is on the right side, whereas concave mirror, center of curvature is on the left side. So center of curvature means center of an imaginary sphere in which the mirror forms a part. Then radius of curvature. Radius of curvature means radius of the imaginary sphere. That means this distance. Radius of an imaginary sphere in which mirror forms a part. So radius of curvature means radius of an imaginary sphere in which mirror forms a part, or you can tell it is a distance between the center of curvature and the pole. This is also different based on sign convention with respect to convex mirror. Convex mirror, as per sign convention, the radius of curvature and center of curvature is on the right side, so it will be positive for convex mirror, whereas for concave mirror it is on the left side, so surely it will be negative. So center of curvature means center of an imaginary sphere in which mirror forms a part. Radius of curvature means radius of an imaginary sphere in which mirror forms a part, or it is a distance between the center of curvature and the pole of the mirror. Now the next one, so center of curvature, radius of curvature, okay. Principal axis. Principal axis means it's an imaginary straight line passing through pole and center of curvature. So this imaginary straight line, so this is a normal line. So the imaginary straight line passing through both the pole and center of curvature is called principal axis. This is also same for our convex mirror. The imaginary straight line passing through pole and center of curvature is called what? Principal axis. So that is principal axis. Now here that question is not asked. Just remember the relation connecting focal length and radius of curvature for all reflecting surface, that is f is equal to r by 2. This equation is also same for concave mirror and convex mirror. So remember this thing. For this question it's not required. So pole means the geometric center of the mirror or midpoint of the mirror is called pole. Center of curvature means center of an imaginary sphere in which the mirror forms a part. Radius of curvature means it's the radius of the imaginary sphere in which the mirror forms a part. Then principal axis, a imaginary straight line passing through both the pole and the center of curvature. Okay, next question. Okay, next question is also based on a numerical. An object is placed in front of a concave mirror of focal length. So the question is based on concave mirror. So concave mirror of focal length. You know that sign convention is very important. Focal length given 12 centimeter. Concave mirror means the focus is on the left side. So you have to give a negative sign. Now, if the distance of the object from the pole of the mirror is 8 centimeter, object distance given, object distance is always, you know that, negative, so minus 8 centimeter. Now, then use mirror formula to determine the position of the image formed. So your question is to find out the image distance V. Draw a labeled ray diagram to justify your answer in this case. So here we have two questions. First question you need to identify the image distance. The second one you have to draw the ray diagram. Ray diagram you can now itself, if you want, you can draw, because the object is, you can see that object distance is 8 centimeter whereas focus is 12 centimeter. So surely the object is in between focus and pole. So last case of concave mirror ray diagram we need to draw. We will draw that after finding image distance. So we can use the mirror formula. Mirror formula is none other than 1 by f is equal to 1 by v plus 1 by u. Our aim is to find out 1 by v. So keep that 1 by v on right side and take this 1 by u to left side. So 1 by v equal to 1 by f minus 1 by u. Now we can substitute the given values. So 1 by v equal to f is minus 12. So 1 by minus 12 minus 1 by minus 8. So in next step, take this sign to numerator. So 1 by v equal to 1 minus 1 by 12. This minus become plus. So plus 1 by 8. Now 1 by v equal to, you can cross multiply here like this. So minus 8 plus 12 divided by 96. Now this will be equal to 1 by v equal to 4 divided by 96. So our aim is to find out the image distance. So image distance v equal to 96 divided by 4. Both are divisible by 2. So 48 divided by 2. That is v equal to plus 24 centimeter. So as we expected, this is a concave mirror, and concave mirror, last case, if the object is between focus and pole, your image is on the behind the mirror, so it is positive. As per our calculation, it is correct, and the image will be a virtual erect enlarged image. Now your first question is to find out the position of the image. Now we need to draw the labeled diagram to justify your answer. So we need to draw the last case of concave mirror ray diagram, because the object is in between focus and pole, because object distance is 8 cm means in between focus and pole. So we can draw the last case of ray diagram. So let us consider a concave mirror. Now let this be the principal axis. Now focus, let it be the pole. Now the object is kept between focus and pole. As per our rules to draw the ray diagram, first rule, a ray coming parallel to principal axis after reflection passes through focus. Now we can use the last rule, a ray incident obliquely towards the pole. A ray incident obliquely towards the pole, reflected obliquely. So you can see that these two rays will never meet on this side of the mirror. So to get the final image, we can extend back. So you can see that the image is formed behind the mirror, and the image will be a virtual erect and enlarged image. As per our obtained answer, the distance from pole to that image distance is 24 centimeter, and pole to this focus is 8 centimeter. So we can mark that also in our diagram. This distance is 24 centimeter and this distance is 8 centimeter. So I think all of you got the answer. Yes. Next question. The image of an object formed by a mirror is real, inverted, and is of magnification -1. So in the question it is given that magnification is -1. Magnification -1 means know that already just now in the previous question we discussed how to treat magnification related question. If it is -1, minus indicate real and inverted, 1 indicate same size. So the characteristics of our given image is real, inverted and same size. So in the question it is telling that in real, inverted and is of magnification -1 if the image is at a distance of 30 centimeter. So the image distance also given in the question. Image distance given 30 centimeter and from the mirror. Where is the object placed? Your question is object distance, and the question it is clear that the image of an object found by mirror is real and inverted. Real inverted image can form only by concave mirror. So the given mirror is a concave mirror or a converging mirror. So we got the mirror So the given mirror is a concave mirror or converging mirror. That's because of real inverted. You know that virtual erect image always forms by convex mirror. So here it's a concave mirror. Concave mirror will form real inverted image, and real inverted image is formed magnification -1. Image distance given 30 centimeter. So you know that real images are always on the left side of the mirror. So as per sign convention, it is -30. Where is the object placed? Your question is, where is the object placed? It's clear, and based on the characteristics of ray diagram, we can easily write, no need of any calculation. You know that when and where this image will be real, inverted and same size if the object is at C. Object is at C, then image also will be at C. That here object is at object distance you need to find out. Image we got at 30 centimeter and is of same size, mean object is also at 30 centimeter. So object distance also 30 centimeter. That's a first question. Where is the object placed? You can tell that object is 30 centimeter or at center of curvature, that is at C. If the object is at C, then only image will be at C. We will get a real inverted and the same sized image. Now give reason to justify your answer. Reason I already told you. If here the object is at C, center of curvature, then only you will get real inverted and same size image. So object distance and image distance are same. Now second question, where would the image be? Where would the image be if the object is moved 15 centimeter towards the mirror? Here center of curvature, that means distance from pole to center of curvature is 30 centimeter. That means we have radius of curvature is equal to 30 centimeter. And as per sign convention, it is -30 centimeter because radius of curvature is on the left side of the mirror. Then you know that the focal length related to radius of curvature by the relation F is equal to R by 2. So that will be equal to -30 divided by 2 equal to -15 centimeter. So the focus is on 15 centimeter. Minus sign indicate it is on the left side of the mirror. Your question is, if the object is moved to 15 centimeter towards the mirror, where would the image be? You know that here the object is at focus. If object is at focus, image will be at where? Infinity. So the image will be at infinity. Image will be at infinity. So if the object is at focus, image will be at infinity. Now draw ray diagram for the new position of the object to justify your answer. So we need to draw the ray diagram by keeping the object at infinity. So we can draw that ray diagram for a concave mirror by keeping the object at focus. So we can draw a concave mirror. Now we can draw a principal axis. So we can mark the focus. Let it be center of curvature. Now as per the question, object is keeping at focus. So as per, we can draw the ray diagram based on our rules. So first rule, a ray coming parallel to principal axis after reflection passes through the focus. Now we can use any other rule we can use. Now I am using the fourth rule, a ray incident obliquely towards the pole, reflected obliquely. So you can see that these two rays will never meet here, and it is assumed to be meet at infinity. So image will be at infinity, and this is the ray diagram you need to draw. So far we discussed important previous year question from Light chapter. We will meet again with another questions from this chapter. Thank you.